Hey, everybody, and welcome back to the Greg and Joe Turbo Show.
Hey,
As always, I'm your host, Joe, joined with my co-host, Greg. Hey, Greg.
that's me. Hi.
Hey, that's Greg. Today, very special guest, I would say. What do you think, Greg? Very special
Oh, the,
guest.
the most special. The most special
Absolutely.
guest we've had yet.
Absolutely.
I
Today,
feel like I need a lot of help. Is that what you're saying?
exactly. Uh, Today we're joined by Justus Gries, longtime Turbo, longtime pre-sales engineer. Hey, Justice, how are you? Thanks for joining. Maybe you can start by just telling us a little bit about yourself.
Thanks for having me. Yeah, I've been here at Turbo coming on 5 or 6 years now. I'd have to go check LinkedIn to see what date it was. My memory is hazy. But yeah, pre-sales engineer. My background, just from a quick elevator pitch, is undergraduate with a computer engineering degree, electrical engineering degree. I have an MBA, which just means I'm an engineer that can hold a conversation. Worn many hats from a network background, compute background, storage background. So kind of just, a merging of a lot of different technologies. And then happy to talk about how Turbo kind of aligns all of those facets together.
Awesome. Yeah, I appreciate that. Yeah, and again, the whole premise of this, the podcast, and the reason that Greg and I sort of set out to do this is because, obviously we work with customers every day. All of us do on this call today. And our job really is about trying to understand the challenges that customers are up against, right? Sort of the trends in the industry that we're constantly butting up against and trying to help customers overcome. So we figured again, it'd be perfect to have you on because you're on the front lines of this, right? You, as a pre-sales engineer, you're working with net new customers, prospects every day. And so I'm sure you kind of hear these challenges probably much more than folks who work on the post-sale side.
Or
So I was hoping to,
even just a different perspective, right? I mean,
I-
we might hear the challenge, but you might hear it in a different way. Share it with the rest of the community to say, look, this is what I hear. This is how I equate things, which may be a totally different perspective than we have on the post sale side.
yeah, good point, Greg.
Yeah.
Good point. So yeah, so I mean, we're hoping that you could, talk to us about, from your perspective, sort of what are some of the, I guess, the big challenges, the big ideas that, customers are kind of coming up against today, and sort of what are some of the ways in which you kind of seek to help them overcome that? Obviously, with Turbo in mind, clearly. And maybe just walk us through that, and then maybe after that we can jump into a quick demonstration.
Sure. Yeah. I think the challenge that everyone's kind of burned with is the same across the board, right? How do you deal with change, constant change, especially change from a technology standpoint, right? I think the humans are the problem or that have the challenge of dealing with change, but that's really what we're managing across the board, right? The shift from, if we look at the computing history from mainframe to now distributed and edge computing and everything in between, right? How do you manage that complexity? How do you drive meaningful, better, progressive change and improve things over time, but also want to mitigate risk, want to make sure that you're doing the right thing? It's a really convoluted, problem to solve. So with that being said, it's like, from a pre-sale side for Turbo, and what gravitated me towards Turbo to begin with was this notion that, the decisions that need to be made are pretty consistent and regular. They just change slightly from environment and operating model, right?
Yeah.
If we talk from the beginning, right, the mainframe, the constrained aspect was the hardware, right? Computing time. And so all the people that needed to work on those systems needed to be flexible, needed to optimize their code, needed to change those aspects around because the thing that couldn't change was the hardware. It was
Right.
expensive, it was heavy, all that. And
Expensive, heavy, all that, but from a perspective of complexity, it was rather simple, right? This SKU, this bill of materials, this thing that you had to interact with inside this box, don't have to worry about any other types of technologies that
yeah,
work with it as well, right?
yeah. And the complexities just stem from there, right? As the great thing about humans are we're trying to solve a problem. We're trying to figure out how to do things better, right? And as we've transitioned from the mainframe days to now bleeding edge with edge computing and microservices, we've just broken apart every bottleneck and tried to figure out how can we do this better? How can we, and there's different avenues. And, I kind of joke historically from like a network standpoint, everyone always says it's a network issue when there's kind of hiccups, which
Yeah,
is
and when
fair
it's
to
not
some.
network, it's storage, right?
Yeah, exactly. But networking was built out of insecure and you weren't guaranteed pathing. So you needed a resiliency protocol that kind of tried to heal itself or fix itself. And then from there, when you start adding on the higher layers, right? The security aspect or what you can and can't get to, right? That's more of a permissions thing, but we treat it as a network issue. Oh, well, the firewall blocked me. Well, why were you on that protocol? What was your intention on that protocol? Why did you need access to that thing? Right. And it starts that conversation of, okay, well, we want to do right, but we also want to mitigate malicious behavior too. So there's always that tug and pull.
Yep.
But when we talk about computing in general, it's really about, breaking down whatever bottleneck it happened to be and trying to optimize that and then move forward. You know, when I was younger, I feel like, when you tinkered with computers and built your own computers, like what was the bottleneck? Was it the processor? Was it the motherboard? Was it the control plane, right? The storage, or, we took a storage, right? Dedicated storage and then turned it into a 3-tiered array for a while, right? Okay, well, flash is quick, but it's expensive. So how do we do that? Right. And so you're always optimizing bottlenecks, sometimes in parallel, sometimes you don't know what the bottleneck is until the new technology comes out. Right. That's what's so great about the landscape now is we have flexibility, but with flexibility, you have complexity. And how do you reconcile the ends of those spectrums?
And a lot of times when you find that bottleneck and you remove it, now you're just pushing the bottleneck down the line, right? You
There's
don't know when
another
that
bottleneck.
bottleneck's going to show up again. What's the next constraint you're going to hit?
Yeah. Whack-a-mole.
Right.
And even when you start talking about that bottleneck, right? And we're dealing with stuff now that have abstraction layers, right? And those bottlenecks are at the abstraction layer points more so than anything. And so now how are you taking a multi-dimensional viewpoint of all of those different attributes? And it becomes incredibly complicated.
Yes. Yep. Math.
Yeah. And let's be honest, humans are fickle creatures, right? We want Schrodinger humans. We want to live in the world where we want consistency, but we want to be dynamic, right? We can't have both be true, but that's the world that we want to live within, right?
Yeah, for sure.
But as with everything, right, there's trade-offs, and trade-offs aren't bad. It really forces you to be creative, figure out, well, those are the trade-offs. Is there another path? And I think that's what's drew me to Turbo when I was first asked, you want to be a pre-sales engineer at Turbo, was it was that unifying between a storage team, a network team, a compute team, and an app team. They're all speaking the same language, or they're all have the same image in their head, but they're just speaking a different language. There's a translation to the data sets.
Or
And
maybe
it's about
maybe they don't have the same image, right? And they've got different toolings where one's saying, "Look, I see an A." The other one says, "That's not an A. That's a B." My tool says
yeah.
it's a B, right?
Yeah, and it's that translation of those data points. And from a previous job where I was at VCE, we're delivering VLOX, it came apparent that from a network physical standpoint to a VMware abstraction standpoint, where the abstraction layers was what were messing people up, right? Someone's like, oh, I have this VM, I have this NIC. Well, that's a VNIC that's still virtualized on an actual physical NIC. And it's the segmentation that was a problem on the configuration of the UCS blade rather than from the VM perspective or the network top of rack switch. But because the VM person didn't have a networking background, didn't have a hardware background, didn't know that nuance, didn't understand those gaps, right? And so it's about being able to have some transparency, or also understand people don't have the same backgrounds or educations, right? Someone that came up from a development standpoint may not have a history in computer architecture. They may not understand some of those fundamentals, and it's not a negative, it's not a bad thing.
Yep.
But how do you make sure that there's transparency in getting that message learned by all the team members consistently is a challenge.
Right. So it's about trying to also, that part of that complexity is also the attempt to sort of lower the barrier of entry, right? To be able to manage some of
Yeah.
these environments. Because to your point, not everyone is an expert in whatever, in storage or a vCenter admin. But that doesn't mean that, with the right processes and platforms in place, right? The idea is to let software sort of handle a lot of this complexity, essentially eliminating the need to be that sort of expert in all areas, right?
Yeah.
Yeah. Yeah.
And we can always learn from someone else too, right? The same is true from, you can have an amazing, person with a storage background, but they may not know app architecture, right? They may not know the fundamentals of how an app is written or how it runs, right? But that's not a negative either, right? Both of those skill sets aren't mutually exclusive to produce a good outcome.
So would you
So
say that, I'm sorry, go ahead, Justus.
No, I was like, and I think that's what Turbo does from, it kind of does that translation, that learning from one tier or one area to another team and doing that unifying of, okay, I'm learning the constraint from the underlying and what's been allocated over it. Those have a relationship and they have an impact on each other. And that's what I need to understand first and foremost before I make a decision.
Yeah, and not always one size fits all. In fact, almost never one size fits all, right? The constraints from a storage engineer at one company or in one specific set of environments with a very specific set of constraints isn't going to translate well to another team or even to another company.
Yeah, exactly.
So it sounds
yeah,
like,
it's a really.
I was just gonna say,
Go.
it sounds like one of the big issues then is essentially just sort of the way modern IT teams are organized, right? Is that everyone's got their own little circle and everyone stays in that silo, right? And it's the spaces in between where things get lost and things get lost in translation, right? And it's about filling those gaps, sort of breaking those walls and essentially creating a larger circle where everyone is within the same thing, right?
Everyone has a piece of the performance puzzle,
Right.
and some people may just have a very micro focus to that piece. Some may have a much larger focus on that piece, but yeah, it's about all the pieces fitting together.
And most oftentimes when you get, for example, you get in these war rooms, right? And these people from all these different, you said the word silos, circles, whatever, they come to the table. The first thing they want to do is say, "It's not me," right? It's not
Meantime to innocence, right? Yeah.
not
Well, it's the
storage.
human.
It was definitely
It's
the
the
other
human
guy.
aspect, right?
Definitely the other guy. 100% the other guy. Yeah.
But
And that's the human aspect, right? We've designed something, and I thought I've accounted for everything, and you may not have, but it becomes uncomfortable. Like, this is a safe space. It becomes uncomfortable to be like, oh, maybe I didn't account for it. But when you're in that high stress and you need to come to an answer quickly, it's easy to be on your guard to say, it's not me, blame someone else, versus let's get our hands in it and figure out the solution. It doesn't matter whose fault it is.
right. Yeah, and not even from a fault perspective, right? I'm not even necessarily talking about just pointing fingers, but just ruling
Yeah.
it out, right? Okay, look, all the indicators that I've got, again, human eyeball on data, are saying it's not me, it's not my team, it's not my domain. So remove me from the equation so that we can stay focused on where it might actually be. And a lot of times, well, not a lot of times, but sometimes, how's that? You'll find that human eyeball looking at that data is wrong. So when you've removed yourself from that equation, you say, great, I'm going to take my domain out of this and take a step back. Perhaps you're going to pay attention. Perhaps you're going to look at the rest of the data and provide an opinion or provide a perspective on it. But I expect most times it's, I've removed myself from the hot seat. Let somebody else explain and look at their domain to try to find out where that root cause is. And maybe that's a disservice at that point. You've said it's not me. You're not looking at the domain, and maybe you aren't paying attention quite as much to other areas of the domain. And you could lengthen that time to resolution.
Yeah. Nail it, right? It's really complicated, right? It's easy to try to remove. The goal is, hey, let's remove as many variables off the table
Right.
that could be contributing, which
Right.
is always a good altruistic goal. But at the same time, it kind of fosters this. Well, I want to step out. I don't want to be pulled into this, right? And so you've
I don't
got
want the spotlight on me.
yeah,
Yeah,
tricky spot to be in.
very, very tricky.
Absolutely. Well, I'm going to say, obviously the folks on this call today, we all are intimately aware and have a, pretty good knowledge of Turbo, and what it does and sort of how it helps our customers through a myriad of different challenges. Um, but again, the idea for this podcast is to sort of get this message out more broadly to folks, within IBM who may or may not be as knowledgeable about Turbo, may or may not have seen Turbo in the past. So maybe it makes sense too, sort of as we're chatting, Justice, if you want to maybe walk us through the UI a little bit and kind of
Yeah.
just show us how, talking about especially like these sort of disparate teams, right, with their disparate tool sets and sort of how Turbo kind of faces that challenge in particular, right? Because I think, starting off that human problem is sort of maybe one of the bigger issues that we face, right? Really at any organization, and sort of one of the first things that Turbo is able to sort of help overcome.
Oh, for sure. And just the visibility aspect of it
Right.
too, right? Hey, how are these relationships interacting with each other? I'm going to share my screen if I can find my share button. Awesome. Cool. So yeah, a couple points, right? Is, our graph on the left, our application supply chain. Um, but I like to envision it as a resource dependency map through the abstraction layers, right? There's a relationship to the VM, to the host, to the cluster, to the storage, and all of these different entities, which, we abstract to, right? An application component is generic, but it can encompass a lot of things, right? And so being able to build this dynamically, especially without agents, I think is a huge value driver, right? Just being able to start with least privilege, right? From a discovery target perspective. Let's just collect the data first and see what's related to each other or what we can glean just from aligning metrics. I think that's a huge value in and itself, right? A lot of times when people have App Dynamics or New Relic or another APM, Instana, built out on top of their applications that, whether it's in the data center, whether it's, in the cloud, there's a relationship, and those silos, those teams don't necessarily get to see those data sets together. And so I think that's one massive differentiator, is being able to tie these relationships together, right? It's not like Grafana or another dashboarding platform where you're just putting all the metrics in one UI. It's getting those metrics in one common fundamental relationship, but then using those data sets together that helps unify those teams, right?
Right. Right.
So
So it's not about just collecting the data. It's about what we're doing with that data once we've collected it, right? That's sort of that next step, that evolution of, okay, cool, great. It's great to have a ton of data, and lots of tools
yeah,
can collect a lot of data, but what are we doing with that data, right? Is the process still a manual process that relies on sort of the human to go and make the connections and correlate the data points and confer with other teams, and try to build the picture, or is the software taking that step for you, sort of building out this picture and then driving actions based on the data we're collecting, right?
yeah. And I also think this ties into, goals and outcomes too, right? Overloaded terminology, in my opinion, right? We use a lot of the same words for different things across the stack, but also overloading the word, right? Automation, right? What do people define as automation, and what it needs to do, and what kind of automation, right? Task automation, right? Knowing to add some CPU or remove CPU, add some memory, remove some memory, add some storage, remove some storage. That's easy to do and automate once you've done an analysis and figured out what do I need to do. But that decision of coming to when and why and how to do it is the complicated part, right? That's the human aspect. And that's really what Turbo is helping to offload a little bit. Let's get that decision making and some of that decision analysis more consistent so we can have a consistent outcome, but still be dynamic, right? I think those are two levels of those extremes that need to be reconciled that people have a hard time with, right? I want everything to be the same to reduce the amount of variables, but I also want to be dynamic. I want to be able to change consistently. And it's like, in what dimension do you want that consistency or that dynamic aspect? And it's difficult, it's complicated, right? This is why we need all the teams coming together, because their little, minor blip may mean nothing in isolation, but when you tie it all together, it's a cascading effect.
Right. Right. There's always a ripple effect, right? I mean, I know when I talk with customers too, I always kind of use the analogy of throwing a pebble into a body of water, right? There's always going to be some ripple. And it's
Yeah.
how do you reliably and safely account for all of those ripples and understand the impact sort of at the outer bands of that, right?
Mhm.
Because there's always going to be some sort of effect from it, from any change, any action. There's going to be some some result of that. So how do you
Yeah.
account for that?
And so the first aspect is really being able to collect data and measure it against the different aspects, right? When you talk about an application as a whole, right, response times and transaction throughputs are measuring from a holistic perspective, but there's also sub-layers to that too, right? The individual transactions that make up that application and their individual components and their individual um, performance variables, their individual response times and transaction throughputs, right? They have their own ever-changing demand and relying on different services, right? So there's a relationship to all these points, but when we start measuring those relationships and then taking the resourcing layers, the resourcing bottlenecks, the resourcing constraints, right? How do they all serve and feed up to that app? And to the earlier comments about how do we mitigate some of those choke points and get better about getting ahead of that and making sure that that's not the reason, right? We're always going to have the age-old debate of it's a code issue or it's a hardware issue. And that debate's never going to go away because it's usually a combination of both,
Mhm.
right? Let's assume that we write perfect code. Perfect code on bad hardware is still going to run poorly, and vice versa. Poorly written applications are not going to perform well on even the best hardware, even the most heavily, designed environment, right? And we live somewhere in the middle on that spectrum, right? We want to be good enough. We want to write good enough code. We want to keep being iterative. We want to keep improving that code, but that's ever changing too, right? I like how we acknowledge that we're imperfect beings, right? We don't write perfect code day one. That's why we have sprint cycles. That's why we have different DevOps practices, right? That's why we have different cadences to do code releases, right? Because we don't write it perfectly, or we need to add new features, or we need to do something different. We've acknowledged that from a code perspective, but we don't apply that to the resourcing layer. If we've got I'm going to use our example. Turbo is, we're on a bi-weekly schedule, right? Trying to push out new code and features and fixes every 2 weeks. Who's to say that that code is going to perform the same on the same amount of resources after 6 iterations? Right? After a quarter, are the resource requirements really the same?
Right.
But we still like to live in this world that resource allocation and utilization doesn't need to be changed for years on end, depending on the company, quarterly, right, monthly. And that's the promise the cloud is really giving us, right? Elasticity, unlimited resources. But if we don't rein that in, if we don't consistently double check, well, what size is the right one? How are we ever staying on top of it, right? We're changing code all the time. We want it to be easier, but if we're not making hardware changes or resourcing layer changes, right, we're not solving the problem.
I think what you're pointing out here, Justice, and correct me if I'm wrong. What I'm hearing from you is that there's a middle ground here, and we need to stay in that middle
Yeah,
ground. The answer isn't hardware or code; it's both.
yeah,
And I've seen a lot of that in my experience, where there's a very real cost for developers, and sometimes that very real cost of fixing that performance problem in code is far greater than just throw more iron at it, right? And I want to come back to that point that it's not an or situation. It should be an and. You know what? We've got a problem right now that requires a little bit more juice. Give it the juice. And then while we're very carefully watching how much juice we're giving, on the backside, let's come back and optimize this thing and spend the time to maybe come to maybe not 100% of what we think the best performance of the code can be, but maybe 50% or even 75, and have that careful balance between good code or better code and not as much hardware, um, which can very quickly spiral out of control. Most especially when you just said it, we have unlimited resources. The only constraint there is the number of dollars.
Well, and to kind of layer on some other complex points to that for that discussion is, right, touching back on earlier, we don't know everyone's background from a code development standpoint too, and where the inefficiency could be,
Yep.
right? A couple of things that kind of come to mind is we do want to mitigate runaway processes, memory leaks, right? That's why we don't let automation run. And that's one of the other values, value props of us is being able to give some of those constraints about max and min. Let's let automation up to a certain point run, but I still want to mitigate runaway processes and memory leaks.
Yep.
Right?
If I hit
The
that
age-old
wall,
debate.
raise the flag, then pull somebody in to say, do we really want to go above that high water mark?
Yeah, and that, let's be honest, that doesn't go away in microservices, right? That's the function of limits on vMem and vCPU, right? That's our safeguard to really say, oh, something's behaving badly, kill it, relaunch it, right? And so we still live in this world where even with latest gen stuff, you may not write perfect code. We don't know every end state or edge case. And we're putting mechanisms in place to help mitigate that type of process. But how do we get back to that middle ground to still let automation work for us, still live within those guardrails, and still be able to provide that consistent analysis and automation and change to get that consistent outcome, but still be dynamic?
Yeah. Yep.
And it's complicated, right? The same decision that needed to be made that way in a microservices standpoint still needs to be made in the mainframe, right? So when our power our power enhancement comes out, right, we'll still be able to help with those decision makings, whether we're looking at from the overloaded mainframe, whether it's the traditional, VMware stack, Hyper-V stack, or the microservices stack, right? The same fundamental framework still needs to be in place. How do I measure data points, use those relationships of the things up and below it, and inform an outcome that we're not going to impact something else down the line?
Yeah, and one of the things I want to revisit, what you were talking about earlier, that aligns very nicely to the sponsored value journey that we use in professional services land, is that idea that you're going to automate the decisions first, and then potentially automate the execution of those decisions later, right? Starting with that idea that, look, this isn't perfect. Let me get an outside opinion on what's happening here. Build some trust in that outside opinion and in those decisions that this outside system, Turbonomic in this case, is building for me. Manually executing those and iterating, again, same process you were talking about with code, to figure out where that sweet spot is and to understand that the policies I've set up or the dials that I've turned and the switches that I've flipped are right for this scenario. I've built my own trust in the automation that's happening for those decisions. I've manually executed those to find that, yes, they are the correct decisions. Now just take myself out of that equation. I've put the work in. I've evaluated that automated decision. Now just let the system make the switch for me.
Yeah. And I think that's critical too, because as we, back to that conversation about, app updates and patching or whatever it happens to be, if we're writing better code, we could probably get by on less resources, right? Our utilization can drop. Or if we're adding more features, we might need more resources. So it's a multidimensional problem. It's not just saying one or the other, but as this code is changing, as that performance variable is changing, let's let the abstraction layers underneath it fall in line, be in alignment, and have that consistent analysis to be able to maintain that steady state, that healthy steady state.
Yeah, because none of these things, making these decisions, none of it's one and done. That's the trap that you're going to do. That sometimes customers fall into is they say, "Oh, I've right-sized a workload. I don't ever have to come back to that thing." Which
we're done here. It's been right-sized.
We're the wrong approach, and nothing stays the same. If I've learned anything in my life,
well, the one what's the one constant? Change, right?
Yeah. Yes.
There's not 100% of anything. Let's look at the landscape and why this becomes so difficult. It goes back to, we still have mainframes. They're still useful. There's still value there, right?
Yes.
We still need to interact with the mainframe. Just because we're a microservice, you could have a microservices DevOps architecture. That doesn't mean that that's the only thing that you need to deal with or interact with. We still need to interact with legacy technologies. Yeah. And the cloud isn't the answer to everything
Right,
either, right?
right.
And the value drivers too, the decisions to be made, whether you keep stuff in-house, whether you outsource stuff, is also a value driver too, right? So all this stuff that you have control over, let's manage it the best we can. The stuff that we've acquiesced or put to someone else, we're holding them to SLAs and SLOs, right? But we still have the same behavior. We still need to align all of those consistently over time. And so, one thing that I love about Turbo and what I feel is the other value driver, besides kind of showing, the different relationships and the entity mappings from the different data sets, is informing above and below. So when we talk about something that's like a JVM, right, that's locked up above the VM, right, it's not just good enough to be looking at what's been allocated, right? We need to be measuring it over time and seeing how healthy or how well is it leveraging the resources that we've given it, right? So when we talk about something like heap, right, how much did we lock up from the OS and the underlying VM, right? How much have we used? And then how frequently are we clearing it out? Are we healthy? Or are we always having to clean it out and add more stuff to it? So then do we need to add more heap? Do we need to give it more memory capacity so that we're not always flushing, right? And so this is where we take that analysis to be able to understand, do we need to actually add more heap? And if we do need to add heap, are we on a VM that has enough capacity to deliver that heap? If not, we have a scale up action on the VM. But is there enough memory on the physical host below it? Yes or no, right? That's why our chain and our directed graph becomes so meaningful, because we use that context together.
Yep.
So if we need to increase heat.
I watched you just now go from a decision about one thing to very quickly two things, and then throwing in the third. The number of combinations for just three things is much greater than just the one that you had initially looked at. Imagine across all of these different dependency points, how many different combinations of things you can get into to find out where that sweet spot is. It's maddening.
Yeah. And that's all we're really trying to do, right? Hey, we want to take this, but maybe we can't take it today, but there still needs to be a decision at the VM layer that maybe another team is managing and owning and need to make decisions around, right?
They're under constraints, right? They might be even under probably under different constraints that I am in the application team. Now, they don't have unlimited. I know we said cloud's unlimited resources, but again, that almighty dollar's there, right? So they don't have unlimited resources. They don't have unlimited whatever they can give whenever they can give it. They have their own constraints that maybe I'm not aware of. So having that visibility, just having the visibility to say, look, here's the challenge that I have. How does that stack up against your challenges? Right here on one screen is pretty powerful.
Well, and two, that kind of also is sort of a differentiator with Turbo, right? Is Turbo is not defining for you, the customer, what good is, right? You, the customer, are leveraging Turbonomic to define good. You tell Turbo what good is via policies. Let us know what the constraints are, right? And then from there, Turbo can do the job of driving you to that good state and keeping you there, right? Because again, optimization, not a one-time deal. If it was, that'd be great. Everyone's job would be super easy, but it's not. It's a continuous process, right? And it's not about crossing thresholds and getting alerts and then sort of chasing fires and putting them out. It's about understanding from day one what good is, getting to that point, and then taking the requisite actions to stay at that place, right? And again, like you said, Justus, doing right by not just you, but all the other teams involved, right? Because nothing exists in isolation, no team exists in isolation, no action exists in isolation. There's an impact globally when we do something, right? So making sure that we're doing right by everyone is important.
Well, and that plays into how much data or how little data and how sensitive to the data is as well, right? Those are other variables just from an analysis perspective, right? Of how much is good, how much is bad, what do we do with it? And now you start talking about outliers. Reason why we use, percentile is because there's a lot of things that happen normally in a state that we don't have control over, right? So when we talk about stuff like our default being a 30-day observation window, right? Longhand, it's, we're doing, a couple minute time slices. So 30 days times 24 hours times 60 minutes, right? That's the sample over the course of a month. But we have backup processes, we have patching windows, we have security scans, we have people logging into a system for the first time, right? Going up to high utilization or going up to 100% utilization isn't inherently bad, right? That's the other trade-off that we need to understand is as we start getting spikes in demand, that's not as means it's performance constrained, but high sustained utilization or high frequent utilization could be performance impacting. So how do we make sure that we kind of whittle away that noise of the normal humdrum of a 30-day window, right? We know we have probably once a month patching and all those things, and not size to those outline events. Because that's the other aspect about automation working for us, right? We don't want our Saturday patching window this weekend to come up and force us to size up all our VMs because security team decided to roll out the new packages,
Yep.
right? And so that becomes
the idea
important
that
in our
one size
analysis.
doesn't always fit all, right?
No. And being able to apply this same analysis, no matter where these workloads live, right? Across data centers, across different cloud instances, right? Now we don't necessarily need to be forced to be in concert with the security teams in their patching processes and their rollout windows, right? Now we can have a better holistic approach. I'm gonna look at this time frame. I'm going to be aware of the performance sensitivity, but I'm not going to just drive to the outliers and keep trying to size up and then consume everything in the estate.
Yeah, I want to come back to something you were just saying there, Justice, where you said that not all the workloads are considered equal. For example, you said hitting that 100% utilization for, let's just say, CPU might not necessarily be a critical problem. Some application, I'll give you an example of one that I've seen in the past, where if you give an application more resources, more CPU, it's going to use it. If you continue to give it more CPU, it's going to continue to use it. And what's the outcome? In this particular situation, the outcome was you're going to get the results of this analysis faster. Well, this customer didn't care about getting the analysis faster because it didn't matter to them. My SLA is to get this analysis in 10 minutes. If I get it in 10 minutes, I can get it down the line. Everybody else is happy. If I get it in 8 minutes, that doesn't save me anything. It doesn't make me any better. If I get it in 1 minute, my business doesn't run any faster because this analysis came out in 1 minute. So that trade-off of spending this much on resources to get an answer back in 1 minute isn't worthwhile. Whereas there are other applications, other different workloads that if you don't have this amount of resource, they fail outright. They just won't run. So that's far more critical than the time-bound application where if I get something faster, it's gravy, but I don't need it.
Yeah. And this is where we can have that collaboration with those app owners and the designers and the architects, right? How do we want this to be elastic too, right? Let's understand that so that we can give you the bounds to help with that, right? Especially when we get to the microservices portion, right? Do we want to be horizontally scalable? Do we want to be horizontally scalable to a certain metric, right? Do we want to be vertical scaling in some way? And then just the complexity and that consistency, CI/CD pipelines from a microservices standpoint, or even a deployment automation, right? How things are living and changing over time isn't necessarily the same of the initial template, right? And how do we reconcile that, right? That's why we got the integration to ServiceNow. Let's create a change request before the change gets happened. So now we know why that change was made. But if we start small and then grow into something, that's a lot easier to do rather than over provision from the get-go and then try to get the genie back in the bottle and scrape those resources back. So how do we operationalize that elasticity safely? It's better to grow into something than start with too much and then try to reclaim it. But yeah, these are all complicated, challenging problems that all of our customers face, right? And every org is different. The political power structure is different across teams, across silos, across orgs, across industry, whatever it happens to be. But that's the great thing about Turbo is that we can attach to all of those. Once we understand some of those challenges and do this translation, we can let this automation work for us across all of these bounds. And that's why, we're not, specific to one industry and valuable just to one industry, because this is a common problem that I think humans have, but it applies to organizations. We want to be the same, but we want to be unique. We want to know what everyone else is doing, that we're doing good, but we want to be a good outlier, but we don't want to be a bad outlier. So how are we managing all of that? Well, what may work for company A may not work for company B, but the outcomes can still be achieved via different policies and different automation paths.
Right, and you get the flexibility then within Turbo, because just we're looking at those that policy wizard there. And again, just to be clear, right? This is this because like you said, not two workloads aren't the same, and so running super hot for one application may be fine, and maybe for another it's not. And again, in Turbo, you have the ability to scope these policies to specific groups of entities, right? So it's not like a one size fits all automation policy where it's like you set it at a global level and now everything's affected the same way. You have the power to say this group needs to follow sort of these rules and these guidelines, these guardrails. This group, something else that makes sense relative to that group. And it's really about sort of carving up your environment and adding the good, right, via the policies to each of those groups, and then letting Turbo go ahead and manage that for you. Because again, like we've discussed, a lot today, it's really it's the complexity, right? It's all how do people manage this without software, without something like Turbo that can sort of offload a lot of this complexity, a lot of this analysis for us, right? And then the automation piece, right? Because again, it's like we start with the picture, right? With the supply chain, we understand sort of the dependency mapping, as you put it. Then we take that analysis, right? We take that understanding, we do our analysis, we deliver actions, but then we go even a step further, right? Great, now we have the actions. Now we can also leverage Turbo to take that next step, right? Which is now go execute those actions. So let's take care of three of the biggest challenges that humans face in IT, right? How do we understand the environment? What's the right decision? And then when should I take this decision, right? Let Turbo take care of those three things for us, and now our job is a lot easier, right? A lot less problems, a lot less fires to put out. And I think it's
Well, and learning rules from different aspects too. So, the VMware team, the hypervisor team, right? We need to live within an HA system, right? We have hardware failures, right? We need to be able to accommodate things out of our control, right? So how much capacity do we need to allocate and keep in reservation, right? Being unutilized in reservation isn't a waste. It's got a very important function, but that function is only valuable when it needs to be used. So I need to be aware that our optimization doesn't utilize that reserve space for our steady state, right? That's the function of it. And so when we pull in HA mission control, right, being able to optimize around the available capacity and how warm or cold, 70%, with a diagram of 10, how do we maintain that 65 to 75% of available capacity? So as more people start loading in more VMs, if that utilization goes up too much, hey, provision another host. You don't have enough HA capacity to support all these VMs, right? So get ahead of that, add that host. But this is the complicated analysis that kind of falls to the wayside a lot of times because we have so many balls in the air. We have so many metrics to be measuring. We have so many teams trying to follow whatever rules that they're trying to pace. Let's try to align that and get that consistent outcome.
And Justus, maybe you could just really quickly kind of elaborate a little bit on this idea of a desired state, right? Because again, I think most customers are familiar with sort of traditional monitoring solutions, right? That leverage thresholds as sort of a trigger for an alert. And so maybe you can just kind of paint the picture high level of sort of how a desired state or what it is, and then sort of how it's different in its approach relative to something like a threshold.
Yeah, great question. So it's really like, where do I want to maintain? And that's really a hard thing to do. We have alerts in place that trigger us to let us know when something's been crossed. Why do we want to know if something's been crossed? Because we need to figure out, was that a good thing or a bad thing? And if it was a bad thing, what do we need to do to get it back in line? Right? It's a lot easier to automate someplace where you want to maintain rather than the billions of edge cases you want to stay away from. And so when you start talking about that desired state of being at 70%, I need to be able to look at all the metrics over time. I need to look at those fluctuations over time. And then I need to be able to manage that, all those utilization rates across all the components together. And so how do I manage? And that's really where our differentiator comes from, and knowing what the impact is, because that's what our analysis is doing. If I move this VM from one host to another host, I need to make sure that I'm not going to put too much load on that host that we get put into a bad spot. right? All of these actions, all of this analysis is comprehensive of each other, right? When we talk about what actions need to be taken, it's not in isolation, but we need to understand what the after impact is going to be to build that trust and that foundation, right? It's easy to say, hey, this host is hot, move it elsewhere. The harder part is, yeah, this host is hot or this host is risky. Let's move it to a better, more well-suited host and not put that host into a bad state.
Right. Let's not solve a problem by creating another one somewhere else.
Absolutely.
Right. Right. Yeah. Excellent. That's a great point. That's a great point.
And so that's consistent across our analysis too. And you can tune that desired state to be more conservative or aggressive. Depends on what viewpoint you want to be on, right? Are you aggressive in cost savings? Or are you aggressive in performance, right? So it depends on how you want to frame that is how our actions change with that variable change. And now we can also apply different analysis to different parts of the estate, right? Let's be more aggressive for a performance standpoint for production, but let's be more aggressive for cost savings at dev test stage, right? So let's fine tune those policies to really extract the value out of maybe the lower life cycle environments where we definitely don't have any level of steady state or consistent, different dev teams at different life cycle processes and different releases and whatever, but they're still using the same shared pool of resources. They may have more dedicated pools in prod, right? So how do we manage all of those trade-offs? We still need to have this platform in place to understand that.
Yeah, that's a common scenario we run into, Justice, is at least for like a pre-production type environment. Dev test maybe doesn't align very much to what I'm talking about, but like for a pre-prod environment, you get customers that say, look, this thing has got to be the same as production. This is where we do our performance tests. This is where we find out about our deltas. This is where we find out about, as best we can, right? Because everyone knows once it hits production, it's a completely different animal.
Yep.
But, how do we solve that challenge? Have we got a way around that?
Well, it really goes to working with those different teams and helping them understand what our analysis does so that we can adhere to those estates better, right?
Yeah.
Let's talk about some of those pre-prod estates. If that's all they're doing is load testing on it, right? Now we can use that to accurately plan for what sizing needs to be in production, right? If our analysis is measured, we're going to do our stress test, this week. Let's tune our analysis to be 7 days in 99.9 for the week of May 15th. And at the end of the week, now we can see what sizing should we be for that heavy load, right? And now we can elevate that into production. And then maybe we power off those machines when they're not being used and free up that capacity, right? There's not one answer to solve for everyone, but this is how we work with those different teams to understand their process today. How do we align with that process and tune our analysis to be able to meet that so that they can be consistent over time?
Yeah, it's a lot better than the typical guess you're going to give, right?
Well, and that's why, spoiler, we're never going to always have a green chain, right? Because there's always that consistent improvement. That's always being able to have to make a change because all these variables are changing over time, week over week, month over month, quarter over quarter, right? But the more we can automate this and work with the architecture and app teams, especially from a resiliency standpoint, right? Now our failovers can be better, and now we can take better sizing, right? Maybe we elevate a bigger size to a new failover cluster, swap it over, and we work with those teams on that flow and let our automation be more dynamic in that regard. But it's also interesting too that, another comment I kind of want to make just from an analysis perspective and outliers and data points, right? I read something a while ago and I don't know what book it was in. It was about computer architecture, but a once in a billion issue happens daily. Look at our clock frequencies, right? 2 gigahertz, a billion iterations happens in a minute, I think, right? So when we start looking at how quickly things change or how utilization changed over time, what code paths we were taking, right? We're living in such nanosecond timeframes, but yet we're still looking at things from a year time frame, right? It's also a juxtaposition of how we analyze that, right? And how we're making those changes. We're okay wanting every ounce of performance. And I'm going to look at the the clock cycle and look at that one outlier, but yet I want to be beholden to a 1 second outlier that was 6 months ago. That's meaningful in this statistical analysis.
Probably not.
That's a good point. That's a good
And
point.
so
I mean, it might
this
be.
is why I like,
Maybe that one data point from 6 months ago cost us $2 million. That might be statistically relevant, right?
but there's other aspects that play into it that aren't necessarily just a CPU highlight, right? What if it was ready wait time, right? What if it was a delay because the CPU couldn't get to the, that VM didn't get to process because we overcommitted the CPUs in that cluster. And it was more of a delay mechanism than a utilization mechanism, right? That's another advantage to our analysis is how do we make those trade-offs? Because as technologists, we still like to live in the world of deterministic and segmented things, right? One CPU isn't one CPU, or two cores aren't two cores. Two cores are just time slices on the processor. You're sharing that same time slice with all the other VMs in that cluster, right? So the only way to unlock that delay mechanism is to release some of the cores that aren't being utilized. And that's another value of our automation. How do we mitigate ready wait time? And that doesn't go away in microservices. That same fundamental problem lives in CPU throttling. Did you exhaust too many clock cycles? And am I going to throttle you for the rest of the time period, right? Because you set your CPU limit. And again, going back to what a CPU limit's for, it's to mitigate the poor stuff, the stuff that we don't know, right? A memory leak, a runaway process, right? And so how are you making those trade-offs day in, day out, minute in, minute out, second in, second out?
Yeah. It sounds difficult. It sounds difficult. I'm going to be honest. It sounds very difficult.
And it is. And so it's really about how do we do all those consistently over time? And we just talked about the on-prem stuff, right? And Greg, you've alluded to it before, but when we started talking about cloud, there's a costing function that's associated with it. And another complicated analysis too is the reserved instance, the coupon clipping, the discounted savings, right? It's really easy to buy a reserved instance and then say, I'm good for 3 years. I pre-committed, right? But what happens when that instance goes under load and it's constrained now? How do you scale it to the right family to meet that need without that reserved instance going to waste? Or better yet, an RI is great for what, about 30% discount? That's awesome to get started, especially from the world of everything runs 24/7. But as we go to the cloud and we have different dev cycles and dev teams and usage patterns, right? Can we park things better, right? If we just park things on nights and weekends when people don't use things during the night and weekend when they're not at the office,
Right.
that's a heavier discount than 30%.
Yes.
Right. So now how are we managing all of that, all of those dimensions, right? Now instance family uptime, plus the reserved instance, plus the size it needs to be in. All of those are inclusive in our analysis. And that's, the cloud providers, the cloud vendors don't give that to you. If you took all of their actions from, whichever provider you want for reserved instance, savings plans, and scaling, that wouldn't align. There are different backends, different problems, and different analyses for those outcomes. And a person or a team of people are trying to figure out what's their best mix to do.
Right. Where's that sweet spot?
Yeah, and I think also too, just important to mention, obviously pretty obvious now, but for those who may be watching this that are not familiar with Turbo, right? Is Turbo is able to deliver this analysis not just for your on-premise estate, right? Not just for, as you see here, your cloud estate, but also your containerized estate, right? It's a single platform to manage your environment, the whole thing, right? I mean, most companies now are hybrid. They have some on-prem, they have some cloud, they have some containers, right? Some combination of these, right? And again, historically, most companies are going to be leveraging different sort of tools for each environment, and there's no crosstalk between them, right? And so now with Turbo being a single platform to unify all of these environments into a single pane of glass, right? Doing the analysis, making the connections, regardless of whether you're on-prem, in the cloud, or in containers, right?
I'm impressing you a little bit, Joe, though. I wouldn't call it a single pane of glass, but a unifying analysis mechanism
Right.
across it, right? Because that's really the goal is I want to make sure that the decisions made in my on-premise state are consistent with the decisions and analysis I'm making in my cloud estate, right? Because I want that consistent outcome. When we talk about, again, those clock frequencies and time on processor, those types of things, those get played into account when you start talking about even the variation of chipsets, which instance family, how many cores, what generation, right? That's all built into our platform to understand those complexities so that we can understand adding 1 or 2 cores is fine in the on-prem side, but the same instance that is appear in the cloud or in Azure, right, with a different chipset, different backend, it may need to be a different family. And so how do we still provide that same consistent outcome with that analysis?
I'll tell you what, Justice, it is clear that you are a wizard of a sales engineer because you do a better job than anyone I've seen, I think, of really sort of explaining the complexity and making me feel anxious. You know, like this problem is so big, right? Like there's so much, like it's not
It's
possible
overwhelming.
yeah, I feel overwhelmed and I know Turbo, but I mean, you do such a great job of sort of illuminating sort of just how big and how complicated you know, managing IT is, right? And I think you do a fantastic job of driving that point
Very
home.
good perspective.
Yeah.
I appreciate that. Just as a side note, I had a cousin who was a little abrasive sometimes. He always made the comment that your weight is your choice you make daily. And it's harsh, but it is. It's your diet, it's your routine, it's your health. Like, what are you doing day in, day out to stay on top of it? I mean, when we talk about this landscape, your performance issues are the alerts that you ignore daily, right? That's the same thing, right? I can't make a decision because I've got so many things to be doing and I don't know what the impact's going to be, right? We need to start somewhere. We need to start with picking up the glass of water. Let's just do better host motions. Let's just do better volume scaling. Let's work our way up to the more complicated automation. But it is achievable. It is easy. We just have to admit it is hard and we need to be managing it better.
Couldn't have said it better myself, Justin. I think that is completely spot on. I want to thank you for joining us today. I mean, this was a fantastic conversation, and again, I think you do a masterful job of sort of walking through the complexity and really highlighting the ways in which Turbo is able to account for a lot of this. So again, thank you for joining. I hope you'll come back. I'm sure we could talk. We could talk for hours. I know we've done it in the past. So
Happy to come back. Love to debate.
Absolutely, absolutely. Well, Greg, thank you as well for joining as always. We're Turbonomic's #1 podcast. I think we can safely say that. We can say that. We own that now. It's fine.
Currently, yes.
But again, thank you for everyone who's watching. Looking forward to putting out more and more of these episodes. We'll have more great guests joining as well, talking about different aspects of IT, of Turbonomic, of Instana potentially, right? Why not?
Yep.
So
and then don't forget our call to action. If you've got an idea, something you want to hear about, holler. We'll do it. We'll make it happen.
Absolutely. Reach out to us. Hopefully there's comments on this video. I don't know how it works. Yeah, it's only our second episode. Right. Is there a like button somewhere?
Like, subscribe.
Like and subscribe, exactly. But no, please reach out to us if you have any ideas of topics or questions you have, because we want to make this as useful for everyone watching these as possible. But thanks again, everybody, and I hope you all have a wonderful rest of the week or weekend, and we'll see you next time. Bye, guys.
Thanks, gentlemen.